Today I'm going to spend a little time working on the flap and aileron skins. What you're seeing here in front of you is essentially a CAD drawing that I've done up from the Zenith plans, showing the side profile of the flap skin. And several years ago I had done a video demonstrating some bending techniques that I'd use, but in that case actually it was just for a very simple right angle piece. I decided to go ahead and document this because these actually are both a little bit more complex pieces. I mean, they've got more bends in them. Actually got a little bit of a challenge here because this angle right here is of course very small, and I don't think unless you've got like access to a press break or something that you would actually be able to bend this directly. So this bend actually right here would be in two parts. First part would be done in my bending brake, and then the second part I actually have to manually work this or press it from the outside using the bending brake as well. So looking over here, what essentially we're looking at, get this zoomed out, is a flattened version of this flap skin. The software that I use called Libre has sheet metal working modeling built into it, so I'm able to go in, essentially define all my bends and get the dimensions that I want, and then I can have it flatten that part out, and I'll be able to go in and measure exactly where I want my bends to go at. So this is the short, of course this is the short bend right here. The one thing that I'll point out, of course I've got a distance from my edge, but the other thing that I do, this line right here indicates what's called a tangent line, which is essentially where the brake will press down at to hold the sheet metal in place. And what I've got right here is a line that corresponds to the very nose of the brake. And what that allows me to do is, of course, there's no way I could, line up under this, so I provide a little bit of an offset for a 1/4 inch radius or 1/4 inch diameter, which is 1/8 inch radius, and put a line right here, and I'll actually use this as my alignment mark. And of course I've done a similar thing for all my other bends that I've got here, those and those. Plus also then I've got the fully developed link, which in this case is 775 millimeters essentially. Then we've got a similar thing here for the aileron. Aileron again is a little bit different of a situation. It does have the commonality that it does have this very acute angle right here that that will actually sort of take two bending operations to be able to complete. But this is also a little unique because this is actually going to require a reverse bend as well. The version of the aileron that I'm bending is the one that takes a hinge. There's another version that Zenith offers as an option to essentially use a strip of aluminum as your hinge instead of using an actual pin hinge or piano hinge. But in this case, I prefer to use the regular piano style hinge. But then that does introduce a little extra challenge of that you've got to deal with this reverse bend, and also the other thing you've got to consider in doing these bends is the sequence. So if you don't think about what bend order you're doing your bends in, then you may find yourself in a situation where you may not be able to bend your part, or it becomes very difficult to bend that part. And I'll go more into bend sequence a little later after I've gotten everything laid out on the aluminum. The only other item I could mention is the flap skin is actually 025 aluminum. The aileron is 016 aluminum. So we've got appropriate pieces of sheet metal. And the other thing is that the flaps are about 8 feet long, and the ailerons are about 4 feet long. And of course I haven't tried to do any bending on this yet, so one thing I don't want to do is just go off and try and do this bend initially with a full width piece of sheet metal. So actually what I'll be doing first, and we'll just slide over here to see that baby, get the camera pointed in the right place, is we've got just a narrow strip. So the profile is the same all the way across, so for at least making sure that I've got my bend set up right, then I'll set up the do just test bends initially to make sure that that my calculations are correct as far as what I've got on the on my CAD software. And actually, after I do that, then I'll also use the final shape that I've got here to validate the drawings that I've done for the rib forms as well as the sheet metal, or the blanks that I'll use for producing the ribs themselves, to make sure that I've got a good tight fit. So at this point, what I'll do is go ahead and start doing my layout on the sheet metal. There's nothing too much exciting there. It's just a matter of just taking careful measurements and drawing a bunch of straight lines. And then after I'm done with that, then I'll do an update. So at this point, I've got the flaps laid out as far as the test profile that I'm doing. I thought I would just point out maybe a few little items here that might be of interest as if someone else were doing this and maybe needed a few tips. So we'll just bring the camera around and down. Now, one thing I've done here is I've indicated a 0 point. The reason I'm doing that, I don't have my zero, I'm not starting right on the edge here, is that actually the first bend I'm going to do is only about 24 millimeters long, which when you're setting that up on the brake is actually not a whole lot of distance to have on the lip, and you'll should be able to understand that better when I actually do the bend. So what I'm intentionally doing is I'm offsetting my 0 point from here, so I've got just a little bit more of a flange here for the leaf of the brake to be able to press and bend this up. One other thing I'll point out here, trying to get things where it's a little easier to see. Should be able to see a little T right here. I put that on there to indicate tangent edge. That's basically the side that will be under the leaf of the brake and actually be pressing down. If you get this backwards, which I've done in the past, and is why I put the little T mark there, your bends will be off. So it's always a good idea to put some kind of a little indicator on there. Like I said, I find T for tangent edge to be a good little reminder. Another item here, which I believe is visible in the camera, I've also numbered my bend sequence, because on this one actually I want to bend the outside first before I start bending the middle. Otherwise I get into a situation where I may not be able to bend the part at all. So just going a little further down, this is the bend that corresponds to the acute 17-degree angle. And you'll notice here actually I've got two T's there. I mismarked something. Something I just thought I would point out real quick that I found useful. Of course, whenever you do layout mistakes, of course, common thing to do is to grab a paper towel, a little bit of acetone, and of course erase that mistake. Of course, sometimes the paper towels are a little bit awkward, so what I found useful to do is just keep a little vial of acetone in it, and then of course use one of these cotton swabs, and then that way you can just dip a little in the acetone. And in this case, actually, I want my tangent edge on that side, but then it makes it very easy. You can just go in and sort of do some fine erasing, where at least I found with the paper towel, it doesn't work quite so well for me, or have a tendency to erase more than what I want. And then moving down a little bit further here to the next position, number 2 position. Again, this will be the second bend that I do. And you'll also notice a little mistake right here. As they say, always measure twice, cut once. I misread my my reading. So actually, I've got 77.5 is the overall developed length of this. And then again, I've allowed for a little bit of overrun here, so that after I've done this bend, I can take a more exact measurement and then just trim that to fit. So between both ends, the only real unknown that I'll have as far as overall length will be the bend that comes from the middle. And again, like I said, for my measuring right there, it's easy enough to come in with this and just sort of erase that out, and I'll reuse these Q-tips numerous times until maybe they get to the point where, yeah, there's too much crud and the water gets a little too colored and sort of looks a mess. So at this point, that does the flap layout. I'll also do a similar operation for the aileron, and if I have anything interesting to point out on that, then I'll take some video. At this point, the layout of the aileron test skin section has been completed, and I decided there were a few other little items I wanted to point out here while I've still got everything set up. One thing I think I neglected to mention earlier was what I'm doing as far as keeping everything in place. Of course, this is a sheet metal, piece of sheet metal that I do my layout on, and of course this is a magnet, and I found this to be extremely useful as far as keeping everything from moving around. If you were just working on the bare wood bench, then of course, short of maybe using tape or something like that, everything has a tendency to sort of scoot around. And of course, the same way with the you've got the aluminum, held down as well. That way, like I said, you're just improving the accuracy of your measurements if you've got a way to keep everything secure. Now, the measurements that are or the bend that's done here is a little bit different than what was done with the aileron. We can try and get that to focus in properly. Of course, on this one we've got the reverse bend, so we've got to take that into account. The thing is actually a little bit simpler than the flap is that actually I don't have any bends after this acute angle right here. So when I do the bend, actually it'll be in order of 1, 2, 3. I won't have to do the outsides and then do the middle to be able to get the bend successfully completed. Now, of course, one thing we do have here, of course, this bend is in the opposite direction to the other bend. So actually, I've got to do a bend from the back side when I do this, and of course that means I have to be able to transfer lines as well. Now, one of the little tools that I've put together that actually helps with this type of situation is nothing more really than a couple of strips of aluminum that I've riveted together, and of course I've got the edges even, and what that allows me to do, everything sort of moved out of the way here, but what that allows me to do is I can line up on my line on this side and get this slid over, and then once I've sort of got that in place, then I can take that piece of metal and flip over to the other side, and I won't try and actually do it right here, but I can flip this over, and then I can transfer my line from the front to the back, so that way I'm able to maintain my or ensure that the line that I've got drawn on this side lines up on the other side so that everything lines up. I guess the other thing I'll point out, of course, this is a test section, and actually I was going through my scrap bin and noticed that I guess this was a piece that at some point, I'm not sure what it came off of, maybe I was possibly from the elevator, but I noticed I had some extra holes here, so this actually made a pretty good test piece to use for this test section. So at this point, what I'll do, I need to do a little bit of trimming up right here. I've got some get this extra off of here because it'll get in the way as I start doing the bend, and I'll start getting everything set up on the brake and demonstrate the bending of the flap and the aileron. At this point, I've got the first flange of my flaps in, and if we zoom in a little bit closer here, I've already got the nose of the brake clamped down, but at this point, I mean, you can see the blue line here, and what I like to do is I'll use like a parallel, for example, to just drop down and make sure that the nose of the brake is lining up with that line. You can try and sight down, but there's too much of a chance of parallax error, at least It's been my experience. I always like to have something else that's at a nice right angle to be able to make sure that I've got that aligned edge here lined up properly. And then the other thing I like to do when I'm doing my before I get the brake clamp down on the metal part is I will secure the aluminum with a couple of magnets just to make sure that it doesn't shift around while I walk over and lock the brake down. So the other thing that I'll point out here is one of the things that I've always done on my metal bending to make it easier to see what's going on. I've always kept a log of all the bends that I've done. So I mean, at this point, I think I've got 1, 2, 3, got like 4 pages of bends that I've done on this project so far. But the advantage is that I'll make a note of like what the thickness is, the angle I was shooting for, the digital angle gauge that I use, what that value was, and then what the actual angle was. Then I may also make a few other notes, like the length of the bend, for example, because I've noticed that sometimes the length of the bend seems to impact the actual bent angle. You know, when I'm trying to shoot for a particular reading on my digital protractor. So at this point I'm doing 016. Now notice up here I've got 025, 72C, which is closed, which is basically what I'm shooting for here. On my digital protractor it was 64 degrees, and the actual angle I achieved when I did it before was 73. So actually in this case I think I went closer to 73 than 72. But probably that small of a difference won't matter. But basically this just tells me when I do my bend that I want to get my digital protractor up to 64 degrees. And then as far as the digital protractor goes, angle down here a little bit. This is just something that I'd bought off Harbor Freight several years ago, and I've used it all throughout my project. And you know, essentially I'll clamp that on there. I do a calibration to basically set the reference to 0 degrees, and then I will start making my bend, and then whenever I reach whatever value that I'm interested in as far as the as far as what the protractor shows, then of course that's where I'll stop, and then I'll take a measurement. And then as far as verifying my measurements, as far as when I'm doing these bends, I'll cover that shortly when I get this first one or one of the other flanges built up. I'll show how I'm taking my measurements to try and make sure that I've actually hit my target. Okay, I've currently got the camera mounted up on the back of my brake here to provide a view of the bend from the backside, which is even a view I haven't seen before. So we'll go ahead and start the bend. The target of our bend is 72 degrees closed. Based on the notes that I've got, I'm shooting for 64 degrees on my protractor. So we'll go ahead and start this and see what we get. Currently at 74 according to the protractor. And 69. 67. 66. Almost about as far as I can go. Okay, 64.1. We'll take a measurement here and see what we've got off of this part. Zoom this out a little bit. Easier to see what's going on. And the angle I am currently showing is about 65, which for the way this is set up, actually I need to add 5 for that. So I'm actually around 70 degrees according to my protractor, so I may have overbent slightly, but for this test profile that's fine. So on the protractor we were around 64, I think it was 64.5. And the reason that the angle is smaller is because you've got to actually, because of spring back, you've got to bend past your actual target. So we'll go ahead and pull this out and see what kind of angle we actually achieved. We're set up for our second bend now. Target is 90 degrees. I'm looking for the protractor to show 68 degrees. Let me double check here. Yeah, 90 degrees, 68 degrees. So do a calibrate, and we'll go ahead and start the bend. And of course, this is 68 degrees getting past 90 on the protractor. Currently at 77, 76, 70.8, and 68. Should be close enough. We'll see what we've got there. For some reason that almost looks like I bent too much. Yeah, I'm thinking we bent a little too much, so we'll see if we can pull that back a little bit. We can get away with that on a narrow profile. Couldn't do it on a, I'm not sure what I looked at. Looked at the wrong value or something. Looking at that, yep. So we're looking pretty good there. So we'll go ahead and pull this and see what we get for a value. Okay, so we got the second one here, and I did have to do a little bit of manual manipulation. We're still off by maybe a few degrees, but at this point it's good enough. I mean, the sheet metal does have a little bit of flex in it here, so I mean it shouldn't have any problems meeting the target. So the next part to do is to get set up to bend, get this middle part bent. At this point we're ready to go ahead and make our middle bend. Now for this to work, the first thing actually I had to do was had to go ahead and trim this down to final size, which the specified length was 25 millimeters, because otherwise it would be able to fit in here. Essentially what I rely on is being able to open this break up far enough that I can go ahead and slide this piece in here. And of course I've got my T-mark there, so we'll go ahead and get this slid on in and get the brake drop down and get everything lined up. So I've got the camera repositioned just to hopefully provide a little bit better view. Now one thing I do realize as I'm doing this is that I should have gone ahead and done my tangent line on the opposite side, because it's quite apparent that I'm not going to get as much bend to here with this long length in the way. So what I should have done is made my tangent line on the other side and then fed in from the back. But that's another good reason to go ahead and do these kinds of tests, because when it comes time to do my 8-foot sheet or do my full-length sheet, I'll be sure to make a note of that, and when I do the full-size sheet, I'll know that next time I should go ahead and and get things set up where I can feed in from the back instead of feeding in from the front. But anyway, we'll go ahead and take this as far as we can. We obviously are not going to get the full 17 degrees that we want here, but we'll take it as far as we can. Okay, so that's about as far as we're going to be able to take it with that. So at this point, I'll go ahead and get the brake opened up again. I will get the piece pulled out, and we'll go ahead and start working on the outside bend. So this is what we've got as far as a bend at this point. Like I said, if I'd have been thinking about it, I should have gone ahead and done my tangent edge from the other side, and then fed this piece in from the back of the fed this side in from the back of the brake, because then I would have been able to get a bit more of an angle than what I've got here. At this point, we'll go ahead and get started with bending the aileron skin test section. So if you recall, this one actually has a reverse bend that we're going to start off with. So on this side, this is where I had it marked out. This side is actually what we want to bend up by 90 degrees. And it looks like it managed to shift on me just a hair, which can happen. Okay, that's looking a little bit more on. Going to shoot for 90 degrees. We overbent a little bit last time for some reason, so I don't know, I've got a 68 degree here. So I think instead we'll probably shoot for 70, and then we'll take a measurement just to see where we're at, just to make sure that we don't overbend like happened on the last one. Okay, I'm stopping at 71.5. And we're just going to take our measurement here. And we are currently probably a little bit over at this point. So I'm not quite sure what's going on with my measurements, if the angle of this table is shifted on me, or something else, or on this leaf is shifted. So we're going to stop the bend right there. Go ahead and pop it out, and we'll do a verification. And yes, it's definitely gone over a little bit. Yeah, so it looks like we're around 84 degrees. So, yeah, I don't know. It's been over a year since I've done any bending, and of course, this is all relative to however the leaf of the brake is laying. So I don't know. Maybe something shifted, or it's hard to say. But I'll just have to be a little bit more careful as I do future bends. Which again, part of the reason for doing test sections is to anticipate problems like this and not have to deal with it, with the real parts. Now this is actually, since this is 016, very easy to bend, so we'll just quickly manipulate this by hand, and it looks like that's close enough. Okay, so for the next part, we've got the middle bend here. And that one is also a 90-degree bend. So we'll make a note here, 016. Let's see, we did 72.5 and we had 86 degrees closed. So since we went about 4 degrees over, I think I'm going to probably stop around, say 75 degrees on this next one. So in this case, unlike the other one, since we have a mix of inside and outside, we can go ahead and move this one. Just flip everything over. Do our alignment check again. Drop the leaf. Everything looks good. Check our angle. Again, we're going to stop at 75 degrees since we seem to be over bending a little bit for some reason. Okay, and there's 75.3 degrees. And that still looks a little over bent, but not as bad as before. So that's claiming I should be dead on at 90. So we'll go ahead and pop it and check it. We're looking like we're about 3 degrees over bent, so the next time I do a 90, I just need to be more careful of that, especially when I start doing the real one. Not be quite so aggressive on my bending and take it in steps. So finally we've got this one, which again, since this is 17 degrees, there's no way we're going to bend this one all the way in one shot. So we're going ahead and getting partial bends done on both of these. So that looks good. See if it held. Yep, looks like it's good. So this we just go as far as we practically can. Which in this case practically is essentially the bar here is running into the nose of the brake, and we don't want to press beyond that because otherwise we could damage the nose bar. So we got a little over 90 on that one. One thing I realized I had neglected to do as I was doing the bends earlier was, in addition to measuring the angle, I should also be measuring the developed lengths as I make the bends. So actually on this part, this is the flap. I already sort of jumped ahead a little bit and had gone ahead and bent this. Didn't catch any video of it because I was doing a little bit of experimenting with bend techniques, but I'll get into that shortly. But what I wanted to cover real quick was just what the bends are as far as what I was trying to shoot for versus what I actually achieved. So actually on this side came out pretty good. I was shooting for 332 and my actual was 332, so that one came out quite nicely. Okay, and then on this side here the target was 317, actual was 319. Now that was actually pre-bend. So it came out a little bit long, but still not bad. I wouldn't, if I was doing a full-sized piece, I wouldn't, doing the full-sized flaps, I wouldn't be scrapping it or anything like that. And then the other thing is I took another measurement after I had gone ahead and bent this section. And it actually may have gone down about 1/2 millimeter or so. Of course, I don't know, 1/2 millimeter is sort of hard to measure as far as sheet metal goes when you're bending it, because it's got so much flex to it. But still, I mean, it's more than close enough. And then finally on this side, the actual was 102 and the target was 103, so that's 1 millimeter. That's good. And then actual bend afterwards was 106, and that's basically just taking into account this little curvature right here, because you only want this to come up as far as where the bend radius actually starts. So again, this one came out pretty well, I think. So then we'll jump over to the aileron. Actually, the aileron did have a problem, but actually that was a problem that I did as far as my drawing goes. So on this side here, get the side up. This side came out pretty good. Came out good. Was shooting for 315 and actually got 315, so that's always good to see. This one did drift a little bit on me. 310 versus actual of 313, and I was shooting for around 310 to 311, so this came out maybe a few millimeters short. Again, not something that I would scrap my part over, but it's a little further than I like to see. And then actually on this side I had a problem that I had the Zenith plans were correct, but then I made a mistake when I was translating everything over. The total height of this should have been 94. And I was shooting for roughly 97. So as far as bend goes, I mean the actual bend was a little under 97, and target would have been a little over, basically within a millimeter. So again, as far as accuracy goes, as far as the bend, that's acceptable. So at this point, I've got my aileron test section set up. Just a few things to point out here. Of course, got my 2 pieces of rubber here that I'll be using to try and keep the radius of the bend from collapsing on me. Another thing, just to try and keep the aileron from scooting around on me. I've got some magnets tacked on here, plus I've got a couple in the back there as well. So we'll go ahead and go for this bend and see what we get. Essentially, all we're shooting for is to get things bent down far enough so that this will more or less rest without too much stress. And of course, while doing this, might have to push that out of the way a little bit, and we'll just get that bend. Still got a bit more to do. Down a little bit lower and apply some more pressure. And we're starting to come down some. And go ahead and hit it again. Again, trying to make sure that I don't collapse this radius down. So at this point, probably not looking too bad. Let's see if we can get it squeezed down just a hairbreadth more. And of course, once the ribs are put in, then of course that's going to help pull everything straight. But the closer you can get the skin to what the final shape is supposed to be, then the better. So yeah, I think that right there will work. Of course, this little bit right here, this is just overrun that I had intentionally added to be able to get that in dimension just a little bit tighter. But at this point, I'm thinking that looks pretty good, and that'll be acceptable as far as a test section goes. So at this point, I'll go ahead. I'm going to go ahead and mark my final line as far as where I want to trim at. And actually, we're pretty close to where we are. All I've got set up here is a parallel that I've got held on with a magnet, and then I've also got a set of gauge blocks. It's just 20 millimeter gauge block. Just make sure that I'm cutting where I need to, which, looking at it, I'm thinking I'm not going to need to do anything at all. We'll check this other side here. Get the magnet on there, tacked on. And yeah, actually we're looking pretty good. It shouldn't be necessary for me to draw an additional scribe line, which means essentially that my calculations for this edge right here were good as well. So we'll go ahead and get this trimmed up and see what it see what it finally looks like. So these are the two completed test sections. Overall, I think everything came out pretty well. Of course, I've got to go back and redo this one because it came out a couple of millimeters taller than it's supposed to be. So really there's only one other test that I need to do, and that's essentially just take a look and see what the flap and the aileron test section look like on the back of the wing itself, just to make sure that everything looks kosher there. So we'll take a quick look at that. So we'll go ahead and do a little mock fit up here just to see how well these test sections seem lined up with the rear channel of the left wing. So just holding this first one up here, and also sort of looking in the camera myself, I'm seeing what I would expect to see. I mean, part of the specification for Zenith was that if the length has been done properly, the top of the aileron or the top of the flap and the bottom of the flap should extend out slightly beyond the end of the rear channel. The exact specification is 3 millimeters, which looks like we're pretty close. I mean, I'm happy with what I'm seeing there as far as that goes. Now this wing skin here, the reason this is under the wing skin a little bit is because I haven't done the final trimming on this yet. But yeah, at this point, yeah, that looks good. And the rear channel is constant width all the way across. So just checking the aileron now to see what we've got. Try and get this somewhat lined up on the top. The aileron skin is just slightly longer than the rear channel. I haven't trimmed it back yet, but just to try and get an idea of what things should look like. I mean, it's looking pretty good. I don't see any real showstoppers at this point, so hard to know exactly what the exact resting position is, but everything looks reasonable to me, especially if I look at it from the bottom side. So I'm thinking this is probably pretty good as well. Of course, this is also keeping in mind that actually the end of this is 2 millimeters longer than it should be. But still, I'm not seeing any major issues or anything as far as the test fit up. So this concludes what I will cover as far as the fabrication of the test sections for the ailerons and the flaps. I do plan on producing additional videos covering the fabrication of the aileron ribs, aileron and flap ribs, as well as the blanks. So if you've got any further questions, just feel free to ask.